What is the academic and biblical origins of Haplogroup J? Welcome to the Hebrew of Israel channel. This next series of videos will answer that exact question, the academic understanding and the biblical understanding of Haplogroup J, and who are they? This is important because we're trying to discover who are the ancient Hebrews of Israel. And some people believe that haplogroup J is Semitic. So this is what we're going to try to figure out and discover. With that being said, we will be using 4 fields of anthropology to figure out this question of haplogroup J, if it is indeed Proto-Semitic in origin and belongs to the Ancient Israelites. But what are the 4 fields of anthropology? So the 4 fields of anthropology is physical anthropology, archaeology, linguistic anthropology, and cultural anthropology. These methods will help us figure out who are the early haplogroup J males. The basic questions we'll have to ask ourselves is this. 1. What are the origins of haplogroup J? 2. What early human ethnic groups that we can study had haplogroup J? 3. What was the culture of these early haplogroup J men? 4. What language did these early haplogroup J men speak? 5. What ancient ethnic groups had haplogroup J? 6. What did these early haplogroup J men look like? And 7. With all this information put together, who would haplogroup J best harmonize with from a biblical perspective? This method will help us figure out who are the early haplogroup J males, because as we know, many ethnic groups lived in the ancient Near East. Who did these early J men belong to? Was it the Israelites or someone else? Because we had Hurrians and Elamites and Gutians and Kazites and Sumerians and Amorites and Semites. All types of people lived in the ancient Near East. So who does J best fit? Furthermore, we also know linguistically that there was various languages other than Semitic that was spoken in the ancient and even modern Near East. So, what language family does early haplogroup J men belong to? Was it the Israelites or some other population, some other group of people? Because we have Semitic, we have Caucasian, we have Altic, we have even Indo-European in the Near East. So who does J belong to the most? These are the questions we must ask ourselves, and I believe it's best to start at the beginning and work your way from the past to the present to be as accurate as possible. And of course, as the scriptures say, I believe it's important to understand the past to remember the days of old. Deuteronomy chapter 32, verse 7 says, "Remember the days of old, consider the years of many generations. Ask thy father, and he will show thee, thy elders, and they will tell thee." That being said, join me on our journey to discovering the biblical and academic origins of haplogroup J. Have a great day. Don't forget to leave a comment, like, share, subscribe, click the bell. But before we get too deep into the video, first I want to tell you guys about my social media platforms. So I have a Clubhouse account, and we can actually talk to one another on it. I also host Clubhouse rooms every now and then where I might talk about history and genetics of the Middle East and Africa. I have a Twitter page, a Facebook account, and a Facebook page, as well as a Instagram, all titled The Hebrew of Israel. And what I typically do on these platforms is post upcoming videos as well as slides for my presentations. And so just be on the lookout for all of that on my social media platforms. And if you want to support me financially for the channel, you can look at my Patreon as well as my PayPal and my GoFundMe. And With all of that out of the way, let's begin with the video. Where exactly did Haplogroup J originate from? Where are the origins and oldest samples of Haplogroup J? This is from IndoEuropedia titled Haplogroup J1 Y-DNA in the Origins and History section, and it says, the first J1 men lived in the late Upper Paleolithic, shortly before the end of the last ice age. The oldest identified J1 sample to date comes from Satserbia Cave, 13,200 BCE, in Georgia, and this is from Jones' 2015 study, placing the origins of haplogroup J1 in all likelihood in the region around the Caucasus, Zagros, Tartarus, and eastern Anatolia during the Upper Paleolithic. Like many other successful lineages from the Middle East, J1 is thought to have undergone a major population expansion during the Neolithic period. The Cherioni 2010 study found that the greatest genetic diversity of J1 haplotypes was found in eastern Anatolia near Lake Van in central Kurdistan. The mountainous terrain of the Caucasus, Anatolia, and modern Iran, which wasn't suitable for early cereal farming, was an ideal ground for goat and sheep herding and catalyzed the proclamation of J1 pastoralis. Having colonized most of Anatolia, J1 herders would have settled in the mountainous regions of Europe, including the southern Balkans, the Carpathians, central and southern Italy, the Alpes, Sicily, Sardinia, southern France, especially Avignon, and most of the Iberian Peninsula. So here is the oldest J1 marker, the late Upper Paleolithic, and as you can see, it is in Georgia where we found it, and the link is in the image for you, and you can type it in to look at the study. This is from Jones at 2015. So again, this is from IndoEuropedia, haplogroup J2, Y-DNA, and it reads in the origins section, haplogroup J2 is thought to have appeared somewhere in the Middle East towards the end of the last glaciation between 15,000 and 22,000 years ago. The oldest known J2A sample at present were identified in remains from the Hotu cave in northern Iran, dating from 9,100 through 8,600 BCE at Lizards 2016, and from Katos in Georgia, dating from 7,940 through 7,600 BCE at the Jones study 2015. This confirms that haplogroup J2 was already found around the Caucasus and the southern Caspian region during the Mesolithic period. And so here is J2A Mesolithic age sample in northern Iran. And again, the link is before you in the image. So this study is called Continuity and Admixture in the Last 5 Millennium of Levantine history from ancient Canaanite and present-day Lebanese genome sequences, and we're going to read the part that deals with the origins of a J marker. Haplogroup J-P58 is frequent in the Arabian Peninsula with proposed origins in the Zagros and Tartarus mountain range. And this is the emergence of Y-chromosome haplogroup J1E among Arabic-speaking populations, and it reads, moreover, the previously described J1 chromosomes frequently found in the Caucasus and eastern Anatolian populations were ancestral to J1E and displayed an expansion time of 9,000 years. For J1E, the Zagros/Tartarus mountain range displays the highest haplotype diversity, although the J1E frequency increases towards the peripheral Arabian Peninsula. And this is from the Ancient Migratory Events in the Middle East, New Clues from the Y-Chromosome Variation of Modern Iranians, and it says, Haplogroup J is predominated in Iran, where both its subclades J2-M172 and J1-M267 are observed. Its highest frequencies are registered in the populations located along the southwestern shores of the Caspian Sea and along the Zagros mountain range. Exceptionally high is the frequency observed in the Balochi and Satrian Balochian in agreement with their likely Caspian Sea origin. And this is one of the latest studies dealing with Haplogroup J. It's from 2021, Origins and Diffusion of Human Y Chromosome J1-M267. And it says, Y chromosome haplogroup J-M304 represents the major male lineage in West Asia today. Around the time of the Neolithic demographic transition, the genome-wide ancestry of West Asian populations was geographically structured into three groups. Among them, haplogroup J-M304 is found in the Caucasus/Iranian and Anatolian hunter-gatherers and farmers, but not in the Levantine ones. Unfortunately, so far, DNA studies are missing from the Arabian Peninsula and Mesopotamia, where haplogroup J-M304 is frequent nowadays. The J1B-F4306 and J1A2-PH77 branches split off at the very beginning. These are the rare lineages distributed mostly along the ancient and modern populations of the Caucasus, the Armenian highland, Iran, and Pakistan. Interestingly, the 13,000-year-old hunter-gatherer from the South Caucasus belongs to J1B-F4306. The J1A1B-7 the J1A1B-Z18375 branch has a geographical distribution subsequently overlapping with that of the J1B-F4306 and J1A2-PH77 branches. The J1A1B-Z18375 branch is found overwhelmingly among ancient and modern populations of the Caucasus, the Armenian highland, Iran, and Anatolia. These branches constitutes the aforementioned peak of haplogroup J1-M267 frequency in the northeast Caucasus. Haplogroup J1-M267 were found among populations living in the Caucasus and neighboring regions. Our Bayesian continuous phylogenetic analysis suggests the origin of haplogroup J1-M267 in West Asia, confirming previous assumptions. Most of the deeply divergent lineages belong to the populations from the northern latitudes of the region, in line with the findings of the late Pleistocene hunter-gatherer from the South Caucasus. Our analysis provides better statistical confidence for the origin of haplogroup J1-M267 in the area encompassing the Caucasus, the Armenian highland, and the Zagros Mountains. So, the origins of haplogroup J and the oldest samples we find of haplogroup J is around Anatolia, Armenia, and Iran, according to all the studies that we have just read. Here is Serbia man. Again, the oldest sample we found of haplogroup J. It is in Georgia, modern-day country of Georgia, and this is in the Caucasus region. And here is basically just a visualization of the map that shows basically where J would have been in ancient times, and still where we find it today. As you can see, Anatolia in Europe, all the way back in the Paleolithic period, and J would have been concentrated around Anatolia, Caucasus, and Zagros, which is, Zagros being modern-day Iran, the Zagros Mountains. And with that being said, here is where we end the origins of haplogroup J, and this is again dealing with all the places where we see haplogroup J and where it would have distributed from, according to the studies given. With Caucus hunter-gatherers and haplogroup J. One of the oldest human populations we can study with haplogroup J are the Caucus hunter-gatherers. They are important for us to understand early haplogroup J men from a geographical and genetic perspective. With that being said, who are Caucus hunter-gatherers? Caucus hunter-gatherers, also called Serbia cluster, is an anatomically modern human genetic lineage first identified in a 2015 study based on the population genetics of several modern Western Eurasian, European, Caucasian, and Near Eastern populations. Jones at 2015 analyzed genomes from males from Western Georgia in the Caucasus. These two males carried Y DNA haplogroup J star, which means one of the oldest forms of J, and J2A, later refined to J1-FT34521 and J2-Y1379 star. Caucus hunter-gatherer, or CHG ancestry, was also found in the Upper Paleolithic specimen from Serbia cave dated circa 11,000 BC, and in a Mesolithic one from Caucus cave in western Georgia dated circa 7,700 BC. The Serbia individual is closest to modern populations of the South Caucasus. So here is the study dealing with it. Upper Paleolithic genomes reveal deep roots of modern Eurasians, and it says we sequenced a late Upper Paleolithic Serbia and a Mesolithic genome from western Georgia at the very eastern border of Europe. We term these two individuals Caucus hunter-gatherers, CHG. We show that Caucus hunter-gatherers belong to a new, distinct ancient clade that split from Western hunter-gatherers, 45 KYA, and from Neolithic farmer ancestors, 25 KYA. This clade represents the previously undetermined source of ancestry in the Yamnaya and contributed directly to modern populations from the Caucasus all the way to Central Asia. So here's a map showing the samples, Serbia and Caucus, basically, as they said, in western Georgia in the Caucasus. And just to show you the time period as well, uh, Upper Paleolithic and Mesolithic, both in Georgia of the Caucasus. So, continuing the reading, it says Caucus hunter-gatherer contribution to subsequent populations. So it says Bichnon, like younger Western hunter-gatherers, shows strongest affinity to Northern Europeans, while contemporary South Caucasus populations are the closest to Caucus hunter-gatherers, thus implying a degree of continuity in both regions stretching back at least 13,000 years to the late Upper Paleolithic. Continuity in the Caucasus is also supported by the mitochondrial and Y-chromosomal haplogroups of Caucus, mitochondrial H13C and Y-DNA J2A respectively, and Serbia mitochondrial K3 and Y-DNA J, which are all found at high frequencies in Georgia today. And so here are the samples, just to show you from the supplementary table. Serbia is J, and so is Caucus. And so, continuing the study, it says Y-chromosome haplogroups. Both Georgian hunter-gatherer samples were assigned to haplogroup J, with Caucus belonging to the sub-haplogroup J2A. In a study exploring J haplogroups in 445 individuals from Eurasia, J2A was found at highest frequency in Georgia and Iraq. It is intriguing that both the mitochondrial and Y-chromosome haplogroups of our ancient Georgian samples have been assigned with the Neolithicization of Europe, with tentatively suggested a genetic link between Georgian hunter-gatherers and early European migrants from the Near East. So, what do we know so far when it comes to Caucus hunter-gatherers? So, for one, we know Caucus hunter-gatherers were from, western Georgia in the Caucasus. And we know that Caucus hunter-gatherers had the oldest haplogroup J markers. So, here's just a closer image of where we found the samples in Georgia in two caves, and it's in the western part of Georgia of the Caucasus. And just showing you again when it comes to the samples and the exact location. So, what did Caucus hunter-gatherers look like? Because we actually also analyzed their phenotype when it comes to these guys. So, the ancient individual from Serbia was a male with black hair and brown eyes. However, the individual is one of the earliest found to carry the derived HERC2 allele for blue eyes. The Serbia individual also likely had light skin, as he was found to carry the derived SLC24A5 allele for light skin. The Serbia individual belonged to mitochondrial DNA haplogroup K3 and Y-DNA haplogroup J1-Y6313 star. About 1.7 through 2.4% of the Serbia individual's DNA was Neanderthal in origin. And so here's from the study, Upper Paleolithic genomes reveal deep roots of modern Eurasians, and it says, like EF are European farmers, but in contrast to Western hunter-gatherers, Caucus hunter-gatherers carry a variant of the SLC2A4A5 gene associated with light skin color. And so here is the supplementary table showing that. So when it comes to the eye color, it's likely that they would be brown-eyed. When it comes to the hair color or the hair shade, it's likely that it'll be dark hair, possibly black to dark hair. And so It says to explore further, we looked at genomes or genotypes in two pigmentations genes proposed to have been strongly selected in the ancestors of modern Europeans, namely SLC45A2 and SLC24A5. Selected SNPs in the SLC4A 45A2 and SLC24A5 genes contributed to lightening of skin and, and are almost fixed in modern Europeans. We found that Caucus and Serbia have the ancestral version of the SLC45A2 variant, but both Caucus hunter-gatherers have the select version of the SLC245A gene, encompassed by the most commonly associated haplotype found in modern populations. We found it most likely that Balachian, Caucus, and Serbia had dark/black hair and brown eyes. So Caucus hunter-gatherers, basically, they were light-skinned, black to dark-haired, and brown-eyed. And personally, I would say Caucus hunter-gatherers had an Armanoid appearance. The Armanoid phenotype is typical of peoples of the Caucasus. So here is the Armanoid phenotype, and basically short-headed and high skull type with fleshy features, a flat occiput, and hooked nose, often dark-haired and light brown skin. And so I would say this would kind of fit the phenotype of the Caucasus hunter-gatherers. It says common in mountainous regions of Asia Minor, especially in Armenia and Anatolia, which is the regions that we're actually dealing with. So this will be the phenotype of Caucus hunter-gatherer, Armanoid. So furthermore, from everything we learned about Caucus hunter-gatherers, this fits perfectly with what we've been seeing and understanding about the origins and distribution of Haplogroup J. And again, this is from the origins and distribution of human Y-Chromosome Haplogroup J1-M267. It says the J1B-F4306 and J1A2-PH77 branches split off at the very beginning. These are rare lineages distributed mostly among ancient and modern populations of the Caucasus, the Armenian highlands, Iran, and Pakistan. Interestingly, the 13,000-year-old hunter-gatherer from the South Caucasus belongs to J1B-F4306. The J1A1B-Z18375 branch has a geographic distribution subsequently overlapping with that of the J1B-F4306 and J1A2-PH77 branches. The J1A1B-Z18375 branch is found overwhelmingly among ancient and modern populations of the Caucasus, the Armenian highland, Iran, and Anatolia. This branch constitutes the aforementioned peak of haplogroup J1-M267 frequency in the Northeast Caucasus. Haplogroup J1-M267 were found among populations living in the Caucasus and neighboring regions. Our Bayesian continuous phylogeographic analysis suggests the origin of haplogroup J1-M267 in West Asia, confirming previous assumptions. Most of the deeply diverged lineages belong to the populations from the northern latitudes of the region, in line with the finding of the late Pleistocene hunter-gatherer from the South Caucasus. Our analysis provides better statistical confidence for the origin of haplogroup J1-M267 in the area encompassing the Caucasus, the Armenian highland, and the Zagros Mountains. So, unironically, or ironically, the regions that we see the origins and distribution of Haplogroup J is Armenia, in the Caucasus region, Anatolia, and Iran, specifically the Zagros region. And the peoples of these regions fit the typical phenotype of a Caucasus hunter-gatherers. Light skin, dark black hair, brown eyes, the Armanoid types. So here again is just a visualization of where we find these early, ancient, and modern J markers in Anatolia, Caucasus, and the Zagros. And this is where we find the Armenids. So an Armenid basically is widespread type found in its most specialized form in the mountains of Asia Minor. And physical traits: light brown skin, wavy dark brown hair, and they're hyper brachycephalic, which basically means a round skull. And the Anatolid type, the Anatolid type is an Armenid subtype of Anatolia with Dravinoid features. The core population lives in West Anatolia. And the physical traits is light brown skin, wavy dark brown hair, and they're also brachiocephalic. And also the Indo-Iranian, a relatively recent contact type with a position intermediate between Indo-Brachioid and Iraniid, widespread in Pakistan, Iran, and Afghanistan, reaching to northern India in the east and Turkey in the west. Physical traits is light to medium brown skin, straight or wavy, brown, black hair, plentiful hair. And so these are the regions where we see J. These are the peoples that live in those regions. So Caucasus hunter-gatherers were from western Georgia and the Caucasus. Caucasus hunter-gatherers carried the oldest haplogroup J markers, and Caucasus hunter-gatherers looked light-skinned, had black dark hair, and brown eyes. This is everything we know from what we gathered about them. So, with that being said, this is the Caucasus hunter-gatherer. Caucasus hunter-gatherers and the Yamnaya culture. Caucasus hunter-gatherer ancestry contributed to an ancient population of people known as the Yamnaya culture. So let's learn about the relationship between Caucasus hunter-gatherers and the Yamnaya culture. Because remember, we know Caucasus hunter-gatherers were an early human population with haplogroup J. Therefore, knowing who they interacted with and mixed with could give us an understanding and idea of who early haplogroup J males were from an genetic and even linguistic level. So, Jones at 2015 analyzed genomes from males from western Georgia in the Caucasus from the late Upper Paleolithic, 13,300 years ago, and the Mesolithic, 9,700 years ago. These two males carried Y DNA haplogroup J star and J2A, later refined to J1-Y6305 star and J2-Y12379 star, and mitochondrial haplogroups of K3 and H13C, respectively. The researchers found that these Caucasus hunters were probably the source of the Near Eastern DNA in the Yamnaya. At the beginning of the Neolithicum at circa 8000 BC, they were probably distributed across western Iran and the Caucasus, and people similar to northern Caucasus and Iranian Plateau hunter-gatherers arrived before 6000 BCE in Pakistan and northwest India. Eastern hunter-gatherers from the Pontic-Caspian steppes have received admixture from Caucasus hunter-gatherers leading to the formation of Western steppe herders, WSH. Western steppe herders formed the Yamnaya culture and expanded massively throughout Europe during the late Neolithic and early Bronze Age. So, the Satsuma individual is genetically closest to an ancient individual dating to around 9700 BP, found at the Katos Clade Rock Shelter in Georgia. Together, they form a genetically distinct cluster referred to as Caucus hunter-gatherers. In comparison to modern human populations, the Satsuma individual is closest to modern populations from the South Caucasus. The Caucus hunter-gatherers contributed significantly to modern European populations by way of the Yamnaya people. Around half of the Yamnaya people's DNA comes from the Caucus hunter-gatherers. The Caucus hunter-gatherers also contributed genetically to modern Central Asians and South Asians. The Proto-Indo-Europeans, i.e. the Yamnaya people, and the related cultures seem to have been a mixture of Eastern European hunter-gatherers, EHGs, and people related to the Near East, either Caucasus hunter-gatherers or Iranian Chalcolithic people, with a Caucasian hunter-gatherer component. Each of those two populations contributed about half the Yamnaya DNA. According to Jones et 2015, Caucus hunter-gatherers' genomes significantly contributed to the Yamnaya steppe herders, who migrated into Europe 3000 BCE, supporting a formative Caucus influence on this important early Bronze Age culture. Caucus hunter-gatherers left their imprint on modern populations from the Caucasus and also Central and South Asia, possibly marking the arrival of Indo-Aryan languages. Beyond contributing to the population of mainland Europe through Bronze Age pastoralists of the Yamnaya, Caucus hunter-gatherer also appears to have arrived on its own in the Aegean without Eastern European hunter-gatherer ancestry and provided approximately 9 through 32% of ancestry to the Minoans. The origin of the Caucus hunter-gatherer component might have been the origin of this Caucus hunter-gatherer component might have been Central Asian, Central Anatolian. So we're going to read from this paper. Upper Paleolithic genomes reveal deep roots of modern Eurasians, and it says, we extend the scope of European paleogenomics by sequencing the genomes of late Upper Paleolithic and Mesolithic males from western Georgia in the Caucasus and a late Upper Paleolithic male from Switzerland. While we detect late Paleolithic Mesolithic genomic continuity in both regions, we find that Caucus hunter-gatherers belong to a distinct ancient clade that split from Western hunter-gatherers 45,000 years ago, shortly after the expansion of autotomically modern humans into Europe and from the ancestors of Neolithic farmers 25,000 years ago around the last glacial maximum. Caucus hunter-gatherer genomes significantly contributed to the Yamnaya steppe herders who migrated into Europe 3000 BC, supporting a formative Caucus influence on this important early Bronze Age culture. Caucus hunter-gatherer left their imprint on modern populations from the Caucasus and also Central and South Asian, possibly marking the arrival of Indo-Aryan languages. Western hunter-gatherers and Caucus hunter-gatherers are the descendants of two ancient populations that appear to have persisted in Europe since the mid-Upper Paleolithic and survived the LGM separately. So here is the LGM, meaning last glacial maximum. So here is a map showing, or a chart showing, Caucus hunter-gatherers, European farmers, and Western hunter-gatherers. They have a common source. So in a sense, you can almost say Caucus hunter-gatherers and Western hunter-gatherers are brothers or cousins in a sense. Here's a closer image. The relationship between Caucus hunter-gatherers, Western hunter-gatherers, and early farmers. So, Caucus hunter-gatherer origins of migrating early Bronze Age herders. So, we find that Caucus hunter-gatherer, or a population close to them, contributed to the genetic makeup of individuals from the Yamnaya culture, which have been implemented as specters for the profound influx of Pontic steppe ancestry that spread westwards into Europe and east into Central Asia, with metallurgy, horse herding, and probably Indo-European languages in the 3rd millennium BC. Caucus hunter-gatherer ancestry in these groups is supported by admixture analysis and admixture statistics, which best describe the Yamnaya as a mixture of Caucus hunter-gatherer and Eastern European hunter-gatherers. So here's a chart showing that. Basically, as they said, the Yamnaya people are a mixture of Caucus hunter-gatherers, as you can see right here, and Eastern hunter-gatherers, or Eastern European hunter-gatherers. That's what makes the Yamnaya. As you can see right here, there is a split in between those two. And on this chart, you can see it as well. But this actually shows you like from an autosomal perspective, which is pretty good. During the early Bronze Age, the Caucasus was in communication with the steppe, particularly via the Maya-Cope culture, which emerged in the first half of the 4th millennium BC. The Maya-Cope culture predated and possibly with early southern influences contributed to the formation of the adjacent Yamnaya culture that emerged further to the north and may be a candidate for the transmission of Caucus hunter-gatherer ancestry. In the admixture analysis of later ancient genomes, the Caucasus component gives a marker for the extension of Yamnaya admixture, with substantial contribution to both Western and Eastern Bronze Age samples. The separation between Caucus hunter-gatherer and both early farmers and Western hunter-gatherers ended during the early Bronze Age, when a major ancestral component linked to Caucus hunter-gatherer was carried west by migrating herders from the Eurasian steppe. The foundation group for this systemic change was the Yamnaya, who we estimate to owe half of their ancestry to Caucus hunter-gatherer linked sources. These sources may be linked to the Maya-Cope culture, which predated the Yamnaya and was located further south, closer to the southern Caucasus. Though through the Yamnaya, the Caucus hunter-gatherer ancestral strand contributed to most modern European populations, especially in the northern part of the continent. Finally, we found that Caucus hunter-gatherer ancestry was also carried east to become a major contributor to the ancestral North Indian component found in the Indian subcontinent. Exactly when the eastward movement occurred is unknown, but it is likely included migration around the same time as their contribution to the Western European gene pool, and may be linked to the spread of Indo-European languages. The discovery of Caucus hunter-gatherer as a fourth ancestral component of the European gene pool underscores the importance of a dense geographical sampling of human paleogenomes, especially among diverse geographical regions. Its separation from other European ancestral strands ended dramatically with the extensive population. Linguistic and technological upheavals of the early Bronze Age results in a wide in a wide impact of this ancestral strand on contemporary populations stretching from the Atlantic to Central and South Asia. So what have we learned so far? Caucus hunter-gatherers descend from an ancient population in Europe. Caucus hunter-gatherers are cousins to Western hunter-gatherers. Caucus hunter-gatherers contributed half of their ancestry to the Yamnaya culture, and the Yamnaya culture are Proto-Indo-Europeans. Therefore, Caucus hunter-gatherers contributed to the ancestry of Indo-Europeans. Modern Europeans actually get their light skin thanks to Caucus hunter-gatherers because the Yamnaya, Proto-Indo-Europeans, derive their ancestry from the Caucus hunter-gatherers. The light skin pigmentation characteristic of modern Europeans is estimated to have spread across Europe in a successive selective sweep during the Mesolithic. The associated TYRP1 allele CLS24A5 and CLC and SLC45A2 emerged around 19,000 years ago during the last glacial maximum and most likely in the Caucasus. The HERC2 variation for blue eyes first appears around 13,000 to 14,000 years ago in Italy and the Caucasus. Caucus hunter-gatherers contributed to the formation of the Yamnaya culture, whereas Yamnaya samples had up to 43% of Caucus hunter-gatherer ancestry. The ancient individual from Serbia was male with black hair and brown eyes. However, the individual is one of the earliest found to carry the derived HERC2 allele for blue eyes. The Serbia individual also likely had light skin, as he was found to carry the derived SLC24A5 allele for light skin. The Serbia individual was also lactose intolerant. The Serbia individual belongs to mtDNA haplogroup K3 and Y-DNA haplogroup J1-Y6313 star. About 1.7 through 2.4% of the Serbia individual's DNA was Neanderthal in origin. Now returning back to this paper, Upper Paleolithic genomes reveal deep roots of modern Eurasians, and it says, to explore further, we looked at genomes in two pigmentation genes proposed to have been strongly selected in the ancestors of modern Europeans, namely SLC45A2 and SLC24A5. Selected SNPs in the SLC45A2 and SLC24A5 genes contribute to lightening of skin and are also fixed in modern Europeans. We found that Caucus and Serbia have an ancestral version of the SLC45A2 variant, but both Caucus hunter-gatherer have the select version of the SLC24A5 gene, encompassed by the most commonly associated haplotype C11 found in modern populations. We found it most likely that Bichon, Caucus, and Serbia have dark and black hair and brown eyes. So this is from Skin Color and Vitamin D. This is an update dealing with that, and it says, interestingly, Eastern and Scandinavian hunter-gatherers had light skin, in contrast to Baltic hunter-gatherers who kept their dark skin only until 3,800 years ago when farming was introduced in this region. by the Bronze Age expansion of people of the Russian steppe origin, which is the Yamnaya, by the way. These migrants were associated with the Yamnaya culture and emerged out of a mixture between light-skinned Caucasus and Eastern hunter-gatherers. The SNP RS142664 within the SLC24A5 gene has the single largest effect on skin lightening of all gene variants identified to date. It is located within a large 78KB haplotype block C11 shared by virtually all carriers of this allele, including ancient Scandinavian, Eastern, and Caucus hunter-gatherers, suggesting that this light-skinned variant derives from a single carrier who lived 22,000 through 28,000 years ago in the Middle East. Similarly, haplotype analysis of the SNP RS16891982 of the SLC45A2 gene concluded that this skin lightening mutation occurred only once in the ancestry of Caucasians. So this is very interesting. And here's just a map showing you that Caucus hunter-gatherers are the ones to really have this lightening of the skin, sort of like the origin point of the light skin. They had the SLC245A mutation, and as you can see right here, these Caucus hunter-gatherers contributed half of the DNA to the Yamnaya, who are the ancestors of Proto-Indo-Europeans, and they would have had light skin. And here are actually reconstructions of Proto-Indo-Europeans, or people of the Yamnaya culture, also known as the Kurgan graves. And so this sort of gives you an idea of what the early Yamnaya looked like. So light skin would have expanded with Proto-Indo-Europeans across Eurasia. And when you look at the expansion of the Indo-Europeans from the Yamnaya region, we see that it does perfectly overlap with that of the Indo-European language and the skin tone of lighter skin. So, when the Yamnaya Proto-Indo-Europeans expanded, there was various Eurasian Y-DNA haplogroups. One of the major haplogroups was haplogroup R, but haplogroup J would have also been part of this Indo-European migration, considering that the Yamnaya are, of Proto-Indo-Europeans derive half of their ancestry from Caucus hunter-gatherers who had haplogroup J. Therefore, it would make sense that haplogroup J was among Indo-Europeans and possibly even has an Indo-European origin. So this is from EUpedia, titled Yamnaya Culture, 35,000 or 3,500 through 2,500 BCE, under the section Who Were the Yamnaya People Genetically, and it says genetic analysis of the Yamnayan genomes conducted by Allentoff in 2015 and Ayek in 2015 revealed that the Yamnayans were a blend of three ancestral populations. The dominant element, 55 to 85%, was the Mesolithic Eastern hunter-gatherers associated with Y haplogroups R1A and R1B. Then came the Caucasian hunter-gatherers admixture, making up about 15 through 25% of their genomes. This admixture is mainly associated with Y haplogroup J, and indeed, one J star sample was found in Mesolithic Russia. It has been confirmed by ancient DNA that J2b was found among Neolithic farmers from eastern Transcaucasia, in this case, northwestern Iran. And there is convincing evidence that these J2b farmers crossed the Caucasus and settled in the Volga-Ural region during the early Neolithic. So let's actually look at these samples. So here's a very old sample of J1 in the Mesolithic age in Russia. And again, it would have been sent there by these groups. And here's a Neolithic sample of J2 in Hungary in Europe. And here's another J2 sample in Neolithic Europe. And there's another J2A sample in Neolithic Europe. And here's a J1 sample in the Chalcolithic age of Turkmenistan, and another J1 sample in Chalcolithic Turkmenistan, and a J2A sample in the Copper age, which means, Copper Chalcolithic age. And here's another one, a J sample in Turkmenistan, Chalcolithic. And here are the various old J samples we find all throughout Europe and all throughout parts of Eurasia. For instance, we found a very old one in France as well. We found one in Mesolithic North Iran, early Neolithic West Iran, Mesolithic Caucasus, Neolithic Anatolia, Lower Austria, which is in Europe, another one in Austria, in Hungary, and so in Hungary, and Copper Age West Iran. So we do find a lot of early old J samples throughout Europe and parts of Eurasia. So it's fairly interesting. And this is why they say, J1 is Anatolian plus Europe. So as I just stated, there are many ancient haplogroup J markers that go as far back as the Neolithic and Mesolithic in parts of Europe. We also find haplogroup J among many Indo-European populations due to the expansion of the Yamnaya, Proto-Indo-Europeans. So here is a map showing the expansion of Proto-Indo-Europeans. And here's a very interesting map showing the Indo-European languages over haplogroup J. And we do see J actually can interestingly fit a lot of Indo-European populations. And this is from EUpedia, the title Haplogroup J1. And it says most J1 Europeans belong to the J1-Z1828 branch, which is also found in Anatolia and the Caucasus, but not in Arabic countries. The Z1842 subclade of Z1828 is the most common variety of J1 in Armenia and Georgia. And this paper is called How Eurasia Was Born, and it says, while early Indo-Europeans who originally crossed from Anatolia in the Bronze Age were most likely represented by various J2 subclades, genetic data suggests that as soon as they reached Central Europe, they assimilated large masses of the native population. And from then on, the rest of their expansion were characterized by more recently formed subclades of the haplogroups characteristic of the native populations. And so here's just a map showing you the expansion of Indo-Europeans, and J being among these early Indo-Europeans. And so here is a map showing the final settlement of the Indo-Europeans in ancient times, and it perfectly fits with Y-DNA haplogroup J. So it's a very interesting overlap that, it's just interesting how much, Indo-European languages and haplogroup J fit one another, specifically haplogroup J2. So what have we learned so far? Caucus hunter-gatherers descend from an ancient population in Europe. Caucus hunter-gatherers are cousins to Western hunter-gatherers. Caucus hunter-gatherers contributed half of their ancestry to the Yamnaya culture, and the Yamnaya culture are Proto-Indo-Europeans. Therefore, Caucus hunter-gatherers contributed to the ancestry of Indo-Europeans. Most Indo-Europeans actually get their light skin thanks to the Caucus hunter-gatherers, and because the Caucus hunter-gatherers, or should I say because the Yamnaya Proto-Indo-Europeans derive their ancestry from Caucus hunter-gatherers, light skin would have expanded with Proto-Indo-Europeans across Eurasia. There are many ancient haplogroup J markers that go as far back as the Neolithic and Mesolithic in parts of Europe, And we also find Haplogroup J among many Indo-European populations due to the expansion of the Yamnaya Proto-Indo-Europeans. That being said, I think this map is sort of a good representation of what went on. And, this is basically, Caucus hunter-gatherers and the Yamnaya culture. The Yamnaya culture. So, what is the Yamnaya culture? We know, genetically speaking, the Yamnaya have Caucus hunter-gatherer and Eastern European hunter-gatherer ancestry. This is from Upper Paleolithic genomes, reveal deep roots of modern Eurasians, and it says, we find that Caucus hunter-gatherer, or a population close to them, contributed to the genetic makeup of individuals from the Yamnaya culture, which have been impacted as vectors for the profound influx of Pontic steppe ancestry that spread westwards into Europe and east into Central Asia with metallurgy, horse riding, and probably Indo-European languages in the 3rd millennium BC. Caucus hunter-gatherer ancestry in these groups is supported by admixture analysis, the admixture statistics, which best describe the Yamnaya as a mix of Caucus hunter-gatherer and Eastern European hunter-gatherers. So here's just a visualization of that from the chart. Yamnaya are 50-50, having Eastern hunter-gatherer, as you can see in blue, and having Caucus hunter-gatherer, as you can see in green. And, the Yamnaya are Proto-Indo-Europeans. So now let's, actually learn about the Yamnaya culture. So this is from Science Magazine. Mysterious Indo-European homeland may have been in the steppes of Ukraine and Russia. What do you call a male sibling? If you speak English, he is your brother. Greek, call him a frater. Sanskrit, Latin, Old Irish, prater, frater, or brethren, respectively. Ever since the mid-17th century, scholars have noted such similarities among the so-called Indo-European languages, which span across the world and number more than 400 if dialects are included. Researchers agree that they can probably all be traced back to one ancestral language called Proto-Indo-European, or PIE. But for nearly 20 years, researchers have debated vehemently when and where Proto-Indo-European arose. Proto-Indo-European was first spoken by pastoral herders who lived in the vast steppe lands north of the Black Sea beginning about 6,000 years ago. One study points out that these steppe land herders have left their genetic mark on most Europeans living today. Fans of the steppe hypothesis are now hailing a genetic study that used ancient DNA from 69 Europeans who lived between 8,000 and 3,000 years ago to genetically track ancient population movements. Among the team's samples were 9 ancient individuals, 6 males, 2 females, and a child of undetermined sex. From the Yamnaya culture north of the Black Sea in today's Russia, beginning about 6,000 years ago, these steppe people herded cattle and other animals, buried their dead in earthen mounds called kurgans, and may have created some of the first wheeled vehicles. Many linguists think Proto-Indo-European already had a word for wheel. The team also retrieved ancient DNA from 4 bones from the later corded wire culture in Central Europe. The comparison of the two cultures' DNA showed that the 4 corded wire people could trace an astonishing 3/4 of their ancestry to the Yumnaya. That suggested a mass migration of Yumnaya people from the steppe homeland into Central Europe about 4,500 years ago, one that could have spread an early form of Indo-European languages, the team concludes. And so here's just a visualization of the migration of Indo-Europeans on the bottom, and on the top, the Yamnaya culture from a genetic perspective. And so both overlap each other. And here's another study from Science magazine called Thousands of Horsemen May Have Swept into Bronze Age Europe, Transforming the Local Population. So it reads, call it an ancient thousand men march. Early Bronze Age men from the vast grasslands of the Eurasian steppe swept into Europe on horseback about 5,000 years ago and may have left most women behind. These mostly male migrants may have persisted for several generations, sending men into the arms of European women who interbred with them and leaving a lasting genetic impact on the genomes of living Europeans. It looks like males migrating in war with horses and wagons, says lead author and population geneticist Matthijs Jacobsen of Uppsala University in Switzerland or in Sweden. Europeans are descendants of at least 3 major migrations of prehistoric people. Finally, 5,000 to 48,000 years ago, nomadic herders known as the Yamnaya swept into Europe. They were an early Bronze Age culture that came into the grasslands. They came from the grasslands and the grasslands or steppes of modern Russia and the Ukraine, bringing with them metallurgy and animal herding skills, and possibly Proto-Indo-European, the mysterious ancestral tongue from which all of today's 40 Indo-European languages sprang. They immediately interbred with local Europeans who were descendants of both the farmers and hunter-gatherers. Within a few hundred years, the Yamnaya contributed to at least half of Central Europeans' genetic ancestry. Using a statistical method developed by graduate student Amy Goldberg in the lab of population geneticist Noah Rosenberg at Stanford University in Palo Alto, California, the team calculated that there were perhaps 10 men for every woman in the migration of the Yamnaya men to Europe, with a range of 5 to 14 migrating men for every woman. Such a skewed ratio arises red flags for some researchers who warn it is notoriously difficult to estimate the ratio of men to women accurately in ancient populations. But if confirmed, one explanation is that the Yamnaya men were warriors who swept into Europe on horses and drove horse-drawn wagons. Horses had been recently domesticated in the steppe, and the wheel was a recent invention. They may have been more focused on warfare with faster dispersals because of the technological inventions, says population geneticist Remus Nelson of the University of California, Berkeley, who is not part of the study. But warfare isn't the only explanation. The Yamnaya people could have been more attractive mates than European farmers because they had horses and new technologies such as copper hammers that gave them an advantage, Goldberg says. The findings that Yamnaya men migrated for many generations also suggest that all was not right back home in the steppe. It would imply a continuing strongly negative push factor within these steppes, such as chronic epidemics or diseases, says archaeologist David Anthony of Hitchwick College in one Unte, New York, who was not an author of the new study. Or he says it could be the beginning of cultures that sent out bands of men to establish new political aligned colonies in distant lands, as in later groups of Romans or Vikings. So here's just a map showing you again the expansion of the Umayyad people from a genetic perspective. And also here is an overlay of the Indo-European languages. And again, it just matches perfectly. And so here is the paper. Massive migration from the steppe was a source for Indo-European languages in Europe. And it says, we generated genome-wide data from 69 Europeans who lived between 8,000 through 3,000 years ago by enriching ancient DNA laboratories for a targeted set of almost 400,000 polymorphisms. By 6,000 through 5,000 years ago, farmers throughout much of Europe had more hunter-gatherer ancestry than their predecessors, but in Russia, the Umayyad steppe herders of this time were descended not only from the preceding Eastern European hunter-gatherers, but also from a population of Near Eastern ancestry. Western and Eastern Europe came into contact 4,500 years ago in the late Neolithic corded wire people from Germany traced 75% of their ancestry to the Umayyad, documenting a massive migration into the heartland of Europe from its eastern periphery. This steppe ancestry persisted in all sampled Central Europeans until at least 3,000 years ago and is ubiquitous in present-day Europeans. This result provided support for a steep origin of at least some of the Indo-European languages of Europe. However, our study shows that a later major overturn did occur, and that steppe migrants replaced 75% of the ancestry of Central Europeans. An alternative theory is the steppe hypothesis, which proposes that early Indo-European speakers were pastoralists of the grasslands north of the Black and Caspian Seas, and that their languages spread into Europe after the invention of wheeled vehicles. Our results make a compelling case for the steppe as a source of at least some of the Indo-European languages in Europe by documenting a mass migration 4,500 years ago associated with the Umayyad and corded wire cultures, which are identified by prominence of the steppe hypothesis as vectors for the spread of Indo-European languages into Europe. So I'm just going to show you sort of like that migration of these peoples from the grasslands of modern-day Ukraine, Russia. And so basically, as I said, in the northern part of the Caucasus, they're going to spread. And there's the Umayyad, there's the northern dialect and the southern dialect. And then you see them going west into Europe, going east into Central Asia, as they said, and some going south into the southern Caucasus and Anatolia. And then they spread even further, going into the Middle East, going into India, and going further west into Europe. And so just to show you that in a quick fashion, it's this, like that. So the Umayyad culture, just covering everything that we learned, the Umayyad culture are the ancestors of Proto-Indo-Europeans. Therefore, they are the ones to spread the Indo-European language. Also, the Umayyad culture were also light-skinned, deriving their mutation from Caucus hunter-gatherers, and the Umayyad culture, Proto-Indo-Europeans, would have spread this light skin across Eurasia. And so this is from Ancient DNA, reveals how Europeans developed light skin and lactose intolerance, or lactose tolerance. And it says, the Bronze Age, around 3000 through 1000 BC, was a time of major advances. And whenever one culture developed a particular advantageous set of technologies, they became able to support a larger population and to dominate their neighbors. The study found that the geographical distributions of genetic variation at the beginning of the Bronze Age looked very different to today's, but by the end, it looked pretty similar, suggesting a level of migration and replacement of peoples not seen in Western Eurasia since. One people that was particularly important in the spread of both early Bronze Age technologies and genetics were the Yamnaya. With a package of technologies including the horse and the wheel, they exploded out of the Russian and Ukrainian steppe into Europe, where they met the local Neolithic farmers. By comparing DNA from various Bronze Age European cultures to that of both the Yamnaya and the Neolithic farmers, researchers found that most had a mixture of the two backgrounds. However, the proportions varied, with the corded wire people of northern Europe having the highest proportion of Yamnaya ancestry. Interestingly, the cultures with the most individuals with this mutation were the Yamnaya and their descendants. These results suggest that the mutation may have originated on the steppe and entered Europe with the Yamnaya, a combination of natural selection working on this advantageous trait and the advantageous Yamnaya culture passed down alongside it could then have helped it spread. Although this process still had far to go during the Bronze Age. This significant study has left us with a much more detailed picture of the Bronze Age Europeans. They had the light skin and range of eye colors we know today. And so here are, what the Proto-Indo-Europeans or the Yamnaya people would have looked like when they spread into Europe. These are Kurgan caves, reconstructions of those bodies. So here is again where light skin would have originated from. One of the branches, one of the alleles, SLC24A5 in the Caucus hunter-gatherer, which would have been passed into the Yamnaya, since the Yamnaya are a mixture of Eastern hunter-gatherers and Caucus hunter-gatherers. They would have been light skinned as well, and they were passed into Europe. And here's just the migration of the Yamnaya and the Indo-European languages, and of course a globe map of indigenous skin tones, most light-skinned peoples being in Eurasia. So, what do we know about the Yamnaya culture? We know, genetically speaking, the Yamnaya have Caucus hunter-gatherer and Eastern European hunter-gatherer ancestry. The Yamnaya culture are the ancestors of Proto-Indo-Europeans. Therefore, Caucus hunter-gatherer contributed to the genetic ancestry of Proto-Indo-Europeans. That's very important. The Yamnaya culture also had light skin, deriving this mutation from the Caucus hunter-gatherers. Therefore, Caucus hunter-gatherers contributed to the phenotype of Proto-Indo-Europeans. And that's sort of where we'll end off with the Yamnaya culture. With that being said, this is where we'll end the video off. And remember, our ultimate goal is to figure out the academic and biblical origins of Haplogroup J. We know the origins of Haplogroup J is in the Anatolian, Caucasian, and Iranian Zagros regions, and we found the oldest Haplogroup J marker among the Caucus hunter-gatherers in the late Upper Paleolithic in western Georgia of the Caucasus. Furthermore, we know that Caucus hunter-gatherers contributed about half of their ancestry into the Yamnaya or the Yamnaya people. Half of the Yamnaya people's DNA comes from this Caucus hunter-gatherers, and the Yamnaya, were the ones who spread Indo-European across Eurasia, going as far west as to Europe and as far east as into Central Asia and even into India. And this is all important because we're trying to figure out, the academic and biblical origins of Haplogroup J. And with all of that information put together, the origins of J in Anatolia, the Caucasus, with Caucus hunter-gatherers being, the earliest haplogroup J individuals we found, and with, half of Proto-Indo-European DNA coming from Caucus hunter-gatherers, and the Umbnea, of course, being Proto-Indo-Europeans, it's highly likely that haplogroup J could be one of the many Y-DNA lineages of Proto-Indo-Europeans. So that's very important and very interesting when this research is put together. And we're not done. But this is where we'll end the video, though, because we've reached over an hour, and I want y'all to, rewatch it, soak up all the information, and we'll go deeper later. But don't forget to like, share, subscribe, click the bell, and leave a comment for any questions you might have. And don't forget to follow the socials that I mentioned, or my socials that I mentioned at the beginning of the video. And with all of that out of the way, have a great day and shalom.